An electrical spark is a brief discharge across a small gap. An industrial arc flash is an explosion. It is an instantaneous, violent plasma expansion inside a metal enclosure. On December 15, 2023, a 29-year-old maintenance electrician at a Stanley Black Decker facility in Ohio suffered severe thermal burns. He was performing a task completed countless times across the manufacturing sector, replacing fuses on an industrial oven. The electrician was interacting with a 480-volt, 60-amp electrical distribution panel. In industrial environments, this is considered on the lower end of the voltage spectrum. This diagram visualizes the timeline and thermal metrics of a 480-volt arc flash. Within 1/100th of a second of ignition, the temperature spikes to 35,000 degrees Fahrenheit. That is hotter than the surface of the sun, instantly vaporizing copper conductors. Maintenance personnel frequently fall into a presumption of safety. Because a task like a fuse replacement is highly repetitive and standard, workers approach the equipment without the required personal protective equipment. Treating electrical maintenance as a secondary, low-risk activity creates an environment where lethal hazards are completely underestimated. Even low-voltage systems generate enough arc energy to ignite flammable clothing. This normalization of deviance turns standard maintenance into a statistical death trap. When repetitive familiarity allows complacency to override physics, catastrophic injury becomes a matter of time. Following the incident, the Occupational Safety and Health Administration initiated a strict forensic investigation of the facility. The investigation revealed the physical cause of the electrician's injuries. The worker was operating around energized electrical equipment without any of the required arc-rated personal protective equipment. But the physical failure was a symptom of an organizational one. OSHA found the facility lacked adequate safe work practices and failed to provide electrical maintenance training to its employees. Specifically, the company failed to maintain and execute written, machine-specific lockout-tagout procedures, directly violating 29 CFR 1910.147. A generic facility-wide LOTO policy is legally and physically insufficient. A blanket policy instructs a worker to shut off the power, but it does not map the actual mechanical reality of complex equipment. As this caution label shows, complex machinery frequently possesses secondary feeds, emergency backups, and interlocking systems that a generalized policy will completely miss. Regulatory bodies investigate a facility's paperwork as rigorously as its physical machinery, because incomplete documentation guarantees behavioral failures on the floor. Catastrophic incidents do not exclusively happen to junior employees. In a separate incident at USS UPI, a highly experienced maintenance supervisor was killed on the job. The supervisor was working near an exposed 13.8 kilovolt switch. Unlike the 480-volt oven, this was a massive high-voltage system. Long-tenured employees often bypass safety steps because they believe their accumulated experience mitigates the physical risk of the equipment. NFPA 70E and OSHA mandate a strict live, dead, live testing protocol. You test the meter on a known live source, test the target equipment to verify zero voltage, and test the meter again to ensure it is still functioning. Visual confirmation of an open switch is entirely insufficient. Mechanical integrity can fail independently of a worker's skill level or years on the job. In the USS UPI case, the mechanical integrity of the switch had failed internally. The mere physical presence of a worker near the exposed terminals was enough to trigger a lethal discharge. The laws of physics do not grant exceptions for seniority. Without strict adherence to isolation and testing protocols, experience is a catastrophic liability. OSHA and the National Electrical Code maintain specific criteria for who is permitted to interact with these systems. The legal threshold is defined as a qualified person. Holding the title of electrician does not automatically make someone qualified for all equipment. A qualified person must demonstrate skills regarding the specific construction of the equipment and receive documented safety training to identify that exact machine's hazards. This diagram illustrates the shock protection approach boundaries, as defined in the 2024 NFPA 70E tables. These invisible radii dictate who is allowed near energized components. The outer ring is the limited approach boundary. An unqualified person cannot cross this outer threshold unless they are continuously escorted by a qualified person and wearing the correct protective equipment. The inner ring is the restricted approach boundary. No unqualified person is ever permitted to cross this line. Depending on the system's incident energy, the arc flash boundary can extend even further than the shock approach boundaries, creating a much wider radius where a worker could receive second-degree burns. The qualified person designation is a measurable physical threshold. It is an access control system designed to keep untrained bodies out of the blast radius. This diagram shows the hierarchy of controls for electrical safety. It provides the framework for building a fail-proof lockout tagout architecture. Notice that personal protective equipment like arc flash suits sits at the very bottom. PPE is the final, least effective line of defense. It mitigates burns when the primary safety plan fails. The primary goal of the architecture is the establishment of an electrically safe work condition, completely removing the worker from the hazard. The first step is mapping every energy source feeding the machine. This explicitly includes discharging stored energy in capacitors, unloading springs, and bleeding off pneumatic pressure. Pushing an emergency stop button or relying on an interlock is an improper lockout method. Control devices do not physically isolate the circuit. Approved disconnecting devices physically sever the energy path. They must be secured with an individual padlock that guarantees the switch remains open. When tasks require multiple workers, a group lockout is utilized. A Hasp allows every exposed person to apply their own lock, ensuring the system cannot be energized until the very last worker finishes their task and removes their key. A robust LOTO architecture relies entirely on impenetrable mechanical barriers and physical locks. It completely removes human memory, assumptions, and convenience from the safety equation. The aftermath of a systemic failure destroys organizations financially as thoroughly as it destroys equipment physically. This chart outlines the direct costs. Severe burn treatment demands approximately 1.5 days in the hospital per % of the body burned, pushing medical costs to $1.5 million. Replacing switchgear destroyed in the blast easily adds another $750,000. Because Stanley Black Decker failed to provide required PPE, OSHA issued a willful violation alongside serious violations for inadequate training and LOTO documentation, proposing over $222,000 in penalties. The financial damage compounds. Historical industry studies apply an 8.25 times multiplier for indirect costs, like litigation, lost production, and increased insurance premiums. The total financial burden for a single event scales between $18 and $35 million. In a court of law, a willful violation means the employer possessed an intentional disregard and plain indifference to human life. It legally transforms an accident into a massive corporate liability. Organizations must shift from treating compliance as an administrative goal to operating with safety as an uncompromising core value. Facilities require a strict de-energization first culture. Any energized work must be treated as a high-risk exception that demands multi-level authorization and justification. This requires real-time verification audits of LOTO procedures and empowering every worker on the floor with absolute stop-work authority. Paperwork alone will never stop a machine from energizing. Only a robust, consistently enforced LOTO system, backed by qualified personnel training, can prevent these tragedies. If you want to learn more about OSHA compliance, LOTO procedures, electrical safety, and preventing catastrophic failures, subscribe to the HSE Study YouTube channel.